Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals involving greatest integer function, right? So here we have this problem that is integral from -1 to 1, and we have greatest integer of 2 minus greatest integer of 3x, right? So let us call this integral as I. Right, so here we'll adopt the method of substitution here, and always remember that the method of substitution in integration is a very powerful method, right? So here what we will do, we'll take t is equal to 3x, right? So we'll assume this term as t is equal to 3x. So dt over dx is now equal to 3, and we can now write dx is equal to dt over 3, right? Okay, now see here the limits of integration varies from -1 to 1. So when x is equal to -1 here, then the value of t can be calculated from this expression. So we have 3 times -1, that is -3, and when x is equal to 1, t is 3 times positive 1, so here we have 3, right? So when x varies from -1 to 1, t varies from -3 to 3, right? So now we can rewrite this integral as I is equal to -3 to 3, and here we have greatest integer of 2 minus, here we can take 3x is equal to t, so we have a greatest integer of t, right? And here we have dt over 3, right? So now we can write this integral as 1 over 3 and -3 to 3. Here we have greatest integer of 2 minus greatest integer of t, right? Okay. So now here we see that the value of t varies from -3 to 3, right? And here we have to write all the integers which lies between -3 and 3, right? So here we have -2, then we have -1, then we have 0, then we have 1, and then we have 2, right? So what we will do now, we'll split this integral as a sum of 1 2 3 4 5 6 integrals, right? So now we can write I is equal to I1 plus I2 plus I3 plus I4 plus I5 plus I6, right? So now here let us assume that this integrand is denoted by the function f of t, right? So here we'll assume f of t is equal to greatest integer of 2 minus greatest integer of t, and here we can now write I is equal to 1 over 3, then -3 to 3, and in place of this function we can write f of t, right? Okay. So now once we have written I in this form, we can write I as the sum of these 6 integrals, right? So in order to save our time, I have written directly the integrals. So I1 is from -3 to -2, right? And similarly I2 is from -2 to -1, and I3 is -1 to 0, and so on. And the last integral, that is I6, is from 2 to 3, right? And each integral carries this factor 1 over 3, right? So now what we will do, we'll separately solve these 6 integrals. So now viewers, let us consider these 6 integrals, right? And here first of all we'll consider the limits. So in I1 the limit varies from -3 to -2, and similarly here I6 the limits varies from 2 to 3, right? So in the first integral, t lies between -3 and -2. In I2, t lies between -2 and -1, and so on, right? So from this information, now we'll write the value of greatest integer of t in these integrals, right? So when t lies between -3 and -2, then by the definition of greatest integer function, the value of greatest integer of t is -3, right? And similarly, when we have t between -2 and -1, then the value of greatest integer of t is -2. Similarly here, greatest integer of t is -1, and here greatest integer of t is 0, and here t lies between 1 and 2, so we have greatest integer of t is equal to 1, and here we have greatest integer of t is equal to 2, right? So once we have decided the value of greatest integer of t, we have to now find the value of f of t in these 6 integrals, right? And the value of or the values of f of t is different in all these 6 integrals, right? So we have defined our function f of t like this, that is greatest integer of 2 minus greatest integer of t, right? So let us take the first case, that is the I1. So here the value of greatest integer of t is equal to -3, right? So f of t is equal to here we have greatest integer of 2 minus, and here we have greatest integer of t, that is equal to -3. So here we have already a negative sign, so here we have -3, and this is equal to greatest integer of 2 plus 3, that is greatest integer of 5, right? So now similarly we can find the value of f of t in I2. So in I2 the greatest integer of t is -2. So if we substitute greatest integer of t as -2 over here, then f of t, we can write the value of f of t here. So we have f of t is equal to greatest integer of 2 minus -2, right? And that is equal to greatest integer of minus plus, so we have 2 plus 2, 4, and that is equal to 4, right? So here we have 4, and similarly in I3 we have greatest integer of t is -1. So when we take -1 here, this is 2 minus -1, so that is equal to +1. So this is 2 plus 1, 3. So we have greatest integer of 3, so that is equal to 3, right? And similarly here we have greatest integer of t is equal to 0. So this is 2 minus 0, that is 2, and greatest integer of 2 is simply 2, right? And here we have greatest integer of t as 1, so we have here 1. So 2 minus 1 is 1, and the value of greatest integer of 1 is 1, and in this case greatest integer of t is 2. So when we take 2 here, see what we will get. We'll get f of t is equal to greatest integer of 2 minus 2, that is greatest integer of 0. So here we have 0, right? So here we have greatest integer of 0, that is equal to 0. So this shows that our last integral is having the value 0, right? So now we can substitute the values of f of t in these 6 integrals, right? So our I was this expression, so now we can write I is equal to 1 over 3 and integral from -3 to -2, and for f of t we'll write this 5, right? Because we have solved this expression for f of t, which is equal to 5, and similarly I2 is from -2 to -1, and we have for f of t that is equal to 4, here 4 dt, and then similarly here we have 3, then we have 2, and then we have here 1, and here we have 0, right? So after substituting the values of f of t, we have this expression. So now here we have simple integrals to solve, right? So now what we will do, we'll take the factor 1 over 3 outside, and then the first integral is from minus 3 to minus 2, and here we have 5 dt, so we can now write it as 5t. Limits are from minus 3 to minus 2, and then we have 4t here, and the limits are from minus 2 to minus 1, and then here we have 3t. Limits are from minus 1 to 0, and here we have 2t. The limits are from 0 to 1, and then here we have simply t. Limits are from 1 to 2, and here we have 0 dt. So this integral is 0, right? So now what we will do, we will simply substitute the limits, and we'll take the difference here. So when we take t is equal to minus 2, so here we have minus 10 plus 15, because here we have minus 3, and then here we have minus 4 plus 8, and then here we have 0 plus 3, and here we have 2 minus 0, and here we have 2 minus 1, right? So now we can simply calculate this value. So we have now 15 minus 10 is 5, 8 minus 4 is 4, this is 3, this is 2, and here we have 1, right? So this is 5 plus 4, 9, plus 3, 12, plus 3, that is 15. So here we have 15, so this is 3 5s are 15, so we have 5, right? So viewers, the value of this integral is equal to 5, right?